Black holes are among the most mysterious objects in the universe. They're places where physics itself seems to say, "Stop, I can't go any further." We can't see them directly, they emit no light. Peek inside? For now, that's pure science fiction. And even our most advanced theories, including Einstein's general relativity, break down right at the edge of the event horizon. And yet, black holes may give us our best chance to understand how the universe works at its deepest level. But one question remains, and it fascinates not just scientists, but all of us. Just how dangerous are they, really? Let's start with the basics. If black holes are invisible, how do we even find them? Well, astronomers have learned to feel their presence by watching how surrounding matter behaves. First, through stars. If a star is orbiting nothing, but something incredibly massive is clearly pulling on it, then chances are a black hole is hiding there. Second, through accretion disks. When a black hole steals gas from a nearby star, that material spirals inward, heats up to millions of degrees, and emits powerful X-rays. That's exactly how many black holes were first discovered. And third, through gravitational microlensing. If a massive, invisible object passes between Earth and a distant star, it bends the star's light like a lens. By studying that distortion, we can tell a black hole is there. So far, scientists have confirmed only a few dozen black holes, but mathematical models suggest there could be as many as 100 million in our galaxy alone. That sounds like a lot, until you remember that the Milky Way contains between 200 and 400 billion stars. So black holes, still incredibly rare.
But how do black holes actually form? For a star to become a black hole, it needs to be extremely massive, at least 18 to 20 times heavier than our Sun. When such a star dies, it explodes as a supernova, and its core collapses under its own gravity. If the density reaches a critical point, it forms an object so compact that not even light can escape. The boundary beyond which there's no return is called the Schwarzschild radius. But what happens inside? We simply don't know. Our laws of physics break down there completely, and that's one of the biggest mysteries in modern science. One of the closest known black holes is V616 Monocerotis, also called A0620-00. It's located just 3,300 light-years from Earth in the constellation Monoceros, the unicorn. This black hole is part of a binary system. Orbiting it is an orange dwarf star with about half the Sun's mass. Together, they complete an orbit in just over 7.75 hours, incredibly fast. Calculations show the invisible companion has a mass of about 6.6 times that of the Sun. That's far too heavy to be a neutron star, so it's almost certainly a black hole. Its gravity doesn't just stretch the star into an oval, it literally pulls gas away from its surface. This material spirals inward, forming a bright, glowing accretion disk. It was precisely this glow that gave the system away to astronomers. And around V1616, there are dozens of other stars, many likely hosting their own planets. Who knows, maybe one of them will someday drift too close and share the fate of the current companion. But that raises an important question. Can black holes even have planets of their own? Many people imagine black holes as cosmic vacuum cleaners, sucking in everything nearby. But that's a myth. At a safe distance, a black hole's gravity is no different from that of an ordinary star with the same mass. So yes, planets could absolutely orbit a black hole, and their orbits could be perfectly stable.
How could such systems form? There are three possible scenarios. First, planets could form from scratch, out of a gas and dust cloud, just like around ordinary stars. The accretion disk around a black hole could provide enough heat to melt ice and even create liquid oceans. Second, if a black hole destroys another star system, some of its planets might settle into new, stable orbits around their new host. And third, Even so-called rogue planets, wandering worlds not bound to any star, could be captured by a black hole's gravity. We haven't found any such systems yet, but the laws of physics don't rule them out.
But what happens if you get too close? That's when tidal forces kick in. First, they strip away the atmosphere. Then they stretch the planet like taffy until it's finally torn apart. The debris spirals into the accretion disk, heats up to extreme temperatures, and vanishes beyond the event horizon. But if you stay at a safe distance, a planet could orbit for thousands, even millions of years, without the slightest risk of being swallowed. In the universe, astronomers recognize three main types of black holes. The first are supermassive black holes. Their mass ranges from millions to billions of times that of our Sun. They sit at the centers of most spiral galaxies, including our own Milky Way. Their accretion disks can outshine entire galaxies. We see them as quasars, visible billions of light years away. The second type is stellar mass black holes. They range from about 5 to 100 solar masses and form when massive stars collapse at the end of their lives. They're likely the most common, but also the hardest to detect. And the third type, primordial black holes, are purely hypothetical. They might have formed just moments after the Big Bang, from tiny fluctuations in the density of the early universe. Some could be smaller than an asteroid, yet incredibly dense. According to Stephen Hawking's theory, such black holes would slowly evaporate, ending their lives in a sudden burst of radiation. Scientists have been searching for these flashes for decades, but so far not a single one has been confirmed. As for quantum black holes, theoretical objects that could form in ultra-high energy particle collisions, they remain entirely speculative. We simply can't create the conditions needed to produce them in any lab on Earth.
So, should we be afraid of them? No, black holes aren't a threat. They're cosmic laboratories, places where the limits of our physics are put to the test. The closest one is 3,300 light years away, and wandering black holes are so rare that the chance of ever encountering one is practically zero. Yes, they trap light. Yes, their interiors remain a mystery, but it's precisely through them that we're learning how space, time, and the universe itself are truly built. Maybe, right now, somewhere in the depths of space, a planet is orbiting a black hole, bathed only in the faint glow of its accretion disk. And on that world, who knows, life could be just beginning. For now, most black holes remain mystery wanderers, silently drifting through the void. And perhaps many of them will stay mysteries forever. But we'll keep searching, because it's in mysteries like these that the true spirit of science lies. Don't forget to subscribe. There's even more fascinating stuff ahead.